Hello, fellow math students. You can see behind me I have a parabola of a snowboarder falling through the air. It's a time lapse, and there's two special places. These are like x-intercepts where you leave the ground and where you hit it again. Let me show you a quick, infamous way to find the x-intercepts. It's called the quadratic formula. Here it is. Looks like this. Something important you should notice, it says x equals. That's right, we're solving for x, the x values of the x-intercepts. That means that y will be 0. Then also notice this weird symbol right here. It's a plus or a minus, which means mathematicians jammed two answers together. Here's one of them, a plus. Here's the other one, the minus. See the difference? Okay, so where does this come from and what am I talking about? Once again, we're dealing with quadratic equations where they say y equals ax squared plus bx plus c. A and b are numbers. They're called coefficients because they're in front of variables. A is in front of the x squared, b is in front of the x. C is also a number. We don't know what it is right now, but it could be any number. So this represents any kind of quadratic equation that you could imagine. A cannot be 0 because if a was 0, x squared would be multiplied by 0 and it would disappear. And the x squared is what gives it that parabola shape. Here, let me show you what I'm talking about. Now I said you can get two answers like this. You have two x-intercepts. One's at -3, 0 here on this green parabola. The other one's at 3, 0. But you don't always have to have two answers. You don't have to have two x-intercepts. Here's another case. There's only one intercept. This parabola is sitting right on the x-axis. There's only one real number answer. And then right here we have a floating parabola. It has no real number solutions. There is a place that this intersects the x-axis, but it doesn't exist in our current number system we have here, with just the real numbers. So three cases. You can get two x-intercepts, one x-intercept, or no x-intercepts that are real number solutions. Flipping back over here, I would like to take this y equals ax squared plus bx plus c, and I would like to turn it into this beast of an equation. Let me show you how to do that. Here's the whole board here. Take a pause, take a look. Let's go to this side note. I had a few of my students multiply this out the other day, and I would like you to remember that x plus b over 2a squared eventually turns into this x squared plus b over 2a times x plus b squared over 4a squared. How do I turn this into the quadratic formula to help me find those x-intercepts really quickly? Let's get into this. We have ax squared plus bx plus c equals 0 because it's a y value of 0 whenever I have those x-intercepts. Now I'm going to divide everything by a in this equation. And that will yield with me so far? If you have any questions, you will not be able to ask me, but maybe some comments and I can address them later. Now check out what I've done here. I'm not going to write everything out for you, but things are happening to be sure. And what I need at the very end is for this equation to say x equals. Now this right here is where you might want to pause and go back and look at what we wrote up top. This will multiply back into x squared plus b over a times x. Now, at this point, you may find yourself asking, what is going on? So it's totally fine if you pause it and you catch up, because that is how you're supposed to understand this. Thoughtful rumination. Okay, here comes the kicker. This is where it all wraps up. What I want to do is get rid of this here square. You're going to get two solutions, possibly. Stay with me. The big reveal. And there you have it. Now remember, that means x can equal negative b plus square root of whatever this is. Or minus the square root of whatever this is. Okay, there's the wonder. There it is now, people.